Good morning, everybody. Good afternoon, good evening, wherever you are. My name is Kakia. I am a Senior Research Officer at the ESRC Business and Local Government Data Research Centre at the University of Essex. And I will be taking you on a journey today of doing data visualization. So telling a story with your data using graphs. That's what we're trying to tackle today. It'd be lovely if you could say hello, because unfortunately I can't interact with you otherwise, but if you could just say hello, use the chat button at the bottom of your screen. And as I said before, if you have questions now or during the course of the webinar, if you could just put them in the Q&A or the chat, and we will address them, we will answer them today, later on during the webinar. I'm joined by my colleague Nigel, who will be helping with any technical difficulties, and hopefully my internet connection will be okay today. So if I break up and I disappear, the whole webinar will not get lost completely. So today, I am my role within the centre is to work with data, work with local authorities, as well as charities and businesses, to help them understand their data. And a big chunk of that work is coming up with ways to represent information that is easily digestible. And it's sort of, in some respects, it's one picture telling 1,000 words, if you may say. So the centre I'm part of is funded by a UK funder called the Economic and Social Research Council. And our mission is to bring together a work from charities in the public sector, as well as the research community, to advance the work around data and methodologies and techniques for data science and artificial intelligence. And we also have a great research interests in the area of in the areas of local economic growth and supporting vulnerable people. So this is sort of kind of bread and butter, really, when it comes to the kind of areas that we actively research on. And we offer quite a lot of support in that journey to these external stakeholders, so non-academic stakeholders, put it like that. So we do training and webinars like the one that you're attending today, but we also offer grant-funded data analytics support for those organizations that are at that stage of their data journey, where they know what data they have and they'd like somebody to analyze it for them. So if you're interested in that area, please get in touch with me or Nigel, and we will be very happy to tell you more about the opportunities offered there. So I'll get straight to the point. So what do we mean by visualizing data, and why should we care? Why are we having this session today to discuss this? So for me, and for many data scientists, data visualization is a graphical representation of information and data. And what we mean by that is to have certain elements in your information, in your data, that you'd like to highlight to a specific audience. And doing that, not necessarily with a long text, with a long report, but using visual elements like charts, graphs, maps. You could use a combination of all these three: nice colors, infographics, big numbers, something that tells you a story about that data, about that information, without you needing to actually look at the whole report and read through it. So visualizing data and reporting and creating reports is an essential part of working with that data. And the opportunity here is that if you do it right, you can summarize the large amounts of information at a glance without the other person having to read through volumes and volumes of text to be able to understand. With that lies a danger as well, in some respects. If you don't do it right, then people will understand something slightly different or very different from what you intended them to. So again, this is why it is important to consider when you're creating a graph. The things I would consider when you create one, either a visual or a graphic or a map or a heat map, would be, first of all, what's the story you're trying to tell about the data? So what are the types of measures? What are the types of features? What are the types of categories that you intend to plot, to put on little drawing. Then the second very important element is, who are you trying to tell that story to? So who is your audience? Is it for yourself to try and understand the data better? Is it for fellow data scientists who are already aware of the data and you're trying to tell them that story? Could it be decision makers within your section? Could it be the general public that might not know nothing about the specific data set and will need to understand what the situation is really quickly? And also, very importantly, what is the key message that you'd like them to take away? What's the story you'd like to tell them with that visual? So the kind of the most useful recipe I've found in the literature about how to create a good visualization comes from a very good book that I would suggest you have a look at by McCandless. And Knowledge is Beautiful, and he has a previous one, Information is Beautiful. And it comprises with 4 elements. So if you have these 4 key ingredients, all 4 of them, you'll end up with a successful visualization. And he says, you need information, so you need data, you need the story, you need a concept, something to tell your audience. And of course, you need a purpose, you need a goal, you need a function. Why are you doing this? You also need a metaphor, an analogy, a visual form that will help you sort of make your point much easier. So I've put it here in a not so nice visual form. His graph about this whole theory is here. And I know this is a very complex visual to start with, but if you can break it down into smaller bits, and I have the link in the source as well for you to go and have a closer look at, and interact with it. And it basically says that if you have 3 of these elements, for example, if you have information, story, and goal, you'll end up with something that is nice but a bit boring. And then same goes if you omit one of the other elements. So it is difficult. It takes loads of thought and loads of work in addition to doing your data analysis. But as I'm sure you've seen infographics or some nice visuals, some nice visualizations of data, if it's done correctly, the message gets imprinted into your mind, and it sort of communicates that information really quickly and at a glance. So how will you be able to choose the best chart for your data? So what would be the best chart of your data? So you remember, data, by data we mean things like text. We could also mean things like numbers. We could mean things like tables. So you could have loads of a variety of information, a variety of data that you might want to visualize. I would recommend you start with the Fantastic 5. So the 5 most basic, most common charts, plots that you basically can't come across. And I would argue that you could create all the different variations. Maybe the maps are not included there, but you could create all sorts of different variations of these by combining 2 of them, not more than 2, I would say, because it gets too busy then. 2 of these to be able to come up with a nice depiction of the data. So I'll go through them one by one in case you were not familiar with them. But I think for those of you that are already familiar with what these visualizations are, the tips, as in the suggestions, good practice, you might find something that you didn't know before. So the bar chart, this looks like, well, a series of bars per category, and the values are indicated by the length of the bars. So each bar is a measured group, and it can be vertical, or they can be horizontal, depending on the information you're trying to visualize. Horizontal bar charts might be good if you have loads of bars to plot, or if your information about the category, the what you call it, is a bit long. Some tips for bar charts is you remember to start the y-axis at the 0 point, because that's what normally our eyes are very sensitive to the areas of bars on the chart. And the assumption is that where you start from is a zero. So if the reader, if you don't follow that kind of rule of thumb, those bars, the viewer will not necessarily understand the right conclusion from your data. Always label your axis so that your viewer understands the proportion and understands what it is that each of the axes shows. Try and put value on labels on the bars if you can, because you don't want people to actually go in and try and do the dotted line to understand what the value is, because that helps people to understand the chart much better. Try to avoid loads of colors. So we say, as a rule of thumb, maybe you can use shades of the same color because that will look better, but don't use maybe more than 3 or 4 different colors, showing, of course, the different categories. So some food for thought there. So the second one that I'd like to touch upon is the line chart. So that is a very helpful visualization tool if you're trying to show change in values over time or across continuous measurements generally, but over time is one of the most frequent ones. So the assumption when somebody looks at a line chart is that the line up shows positive change, the line down shows negative changes. So try not to create a line chart that is against that assumption, because people again will draw the wrong conclusions. A line chart is also very helpful when you have values from the past up to the present, for example, and you'd like to draw a line projecting or predicting values to the future. So there you will see line charts starting with one line, then coming up to a temporal point like today, and then maybe you have 1 or 2 different lines with the different prediction futures or the different scenarios. So again, that is a very helpful way to, at a glance, see what it is that your data is telling you or is predicting, actually. And the very interesting thing and helpful thing about the line chart is that you can combine multiple line charts together. So you can have more than one line showing more than one trends, but you can also combine them with bar charts. So again, can give you a very effective kind of visual if you combine more than one variables. So some tips, some best practice for line charts. Again, clearly label your axis. You might see a pattern for this. Try and remove chart elements that are taking away, do not add any information, but are taking away, are distracting the viewer from the key message you're trying to portray. So you have grids, if you have loads of colors, if you have big legends, if you have big titles, this might take away or distract the viewer from the key message. If for some reason you are trying to focus on a specific area of the line chart, consider, and you're trying to focus on this, see whether you could change the scale of the y-axis to make it easier to read. So if, for example, you have let me go back to the previous graph. So if you had that line wasn't as that trend upwards wasn't as clear here, and we had a scale. So here we have it from a scale from 0.675 all the way to 0.80 maybe. But if this was from 0 to 1, maybe that line did not show that high peak here, so it would be a bit flatter. So consider changing that the y-axis scale to be able to demonstrate that trend better if you need to. And as we've said, for the bar chart, avoid having more than 5 lines in a single chart. Consider, if you need to, consider whether you need to use multiple of these line charts, so that your message again is clear and not cluttered. The third plot I'd like us to have a closer look at is the scatter plot. So this is, again, you have the Y vertical and the X axis, the horizontal one. and you have lots of dots distributed across space. So scatter plots are really good for showing relationships. So relationships between two variables. So it's one of the so bar chart, line chart, you could not visualize relationship between two different variables. It always had to be over time, or for the bar chart, you only had the categories, and then you had the y-axis for the numbers, so to show you where you're at. The scatter plot will show you values for two numeric variables. So you will plot one variable on the horizontal, the y-axis, and another variable on the x-axis, the vertical. Sorry, the x-axis, the vertical one. Sorry, I got myself confused there. And the x-axis for the horizontal one for the other variable. And what that will show you is how one is related to another by putting the dot in the right place. So a scatter plot is also very helpful if you're trying to understand the type of relationship between these two variables. So how concentrated these dots are, and in which space, in which part of the graph will show you, for example, if they are strongly correlated. So if they are dense, they're close to one another, the dots, that shows strong correlation. If it's weak correlation, they will be a bit more dispersed. You can have the positive negative relationship depending on whether they go upwards or downwards. And then you can see if they have a linear or non-linear relationship, again, depending on where they sit, whether they are all close together in one, in something that could look like a line or not. So finally, it's also a very helpful plot to see if you have any outliers in the data. So these are the values that don't normally follow the same trend as the other dots. And you can also identify gaps in the data. So places of the chart where you have no dots at all will show you that you have a gap in your data. Very briefly, just to get a good feeling about what that does. The box plot is another one. So this is the box. I'm sorry, this is my dog. So this is the box. The lines at the top and bottom, we call these whiskers. So these lines, the whiskers, summarize the distribution of values within these measured groups. The position of the box and the whisker ends shows where the majority of data lies. And the line in between shows you the mean of that data. So it's, again, at a glance, quite a lot of information about the data and the specific variable. And it's super helpful when you're trying to compare multiple groups to one another. Finally, the king of them all, the pie chart, used by loads of people in all sorts of different ways, some correct, some not. I'm going to give you some tips about them at the next slide. So pie chart is super helpful when you're trying to compare parts of a whole. When you have the full population, so when you have the whole total of them and you're trying to tell us what proportion of that whole each of these categories occupies. So you can have this pie chart in loads of different variations, but some good design suggestions would be that you try and order segments from the greatest to the least. So here you see in the example I have, we have 60% coming first, the vegetables, then protein 20%, and then goes all the way to 10% for the fruit, dairy, and peanuts. And it is advisable that you start your pie at 12 o'clock. So you start with the larger value and 12 o'clock, so that the eye can actually follow from the largest to the smallest one all the way around. If possible, limit the number of segments you use. If, for example, you have loads of 1% or 0.something%, consider grouping them if needed. Again, depends on what your message is. So if you wanted to focus on that 0%, then maybe you need slightly different way of visualizing that. So some tips for the pie charts. Mistake we all make sure your segments up to 100 if this is proportion. So if it's percent, It's an obvious mistake and common mistake. Try and keep it as clean and consistent as you can. And as I said, try and group some categories if you need to show maybe a larger percentage if needed. If you, for example, you had this pie chart and all of them were around 20%, then that wasn't a very good way of showing the differences in your data. Maybe a better way to show that would have been to use the exact numbers and use a bar chart. And try and make it, again, as less cluttered as possible. I would suggest you avoid using 3D. If you like it, then that's fine too. But the flatter and the neater you keep it, the easier it is for the viewer to read or for the reader to actually look at the graph and understand the data. So in trying to choose the best chart for your data, because these are just 5 of the more basic ones, I would like to give you one of the best kind of frameworks I've come across in the literature around that, which is summarized in 5 elements. So the first one would be so all of these 5 ones are the functions of your chart. So you need to consider to be able to understand or sort of gauge which would be the best chart for your data, to sort of have it in the back of your mind what it is that you're trying to do. What is the function? What is the objective of your visual? So, and you in this framework, you get different suggestions, different examples of charts you could use for each of the 5 different functions. So if you're trying to inform people, if you're trying to compare values or groups, if you're trying to depict change over time or over locations, if you're trying to organize or cluster your data, and if you're trying to show relationships amongst your variables. So I'm going to take them one by one, hopefully giving you a kind of decision tree of some sorts to be able to, next time you're asked to do a visualization, maybe if a table was your default, maybe you could consider if a chart would be available, or if you're already using charts in your work, maybe you would consider if there's an alternative that's better showing the relationships or the organization that you want to depict. So I've gone through this. So let me take the first one, which is the purpose of your visualization to inform. So if you're trying to inform, I would suggest you go with numbers or donut charts, as I've shown you before, or a pictograph that simply shows proportion. So a single big number, if you have a data point, 20 million, is a good way to sort of focus the information and give people the right information that they need. So consider, for example, this visual. So it's using a kind of icon of a man or of a human. Some people will say, why do you have a man and a woman? But for now, let's focus on that. And then they are trying to showcase the proportion of people by coloring the icon the 25%, 50%, and 75%. So you can see some interesting and imaginative ways you could do that. You might have done it with a pie chart, but here's an example of using a combination of them too. So, so a single big number, consider a donut chart or a pictograph, which is what I showed you just now. If you're just trying to inform people of big data points, big data values. Now, if you're trying to compare, these charts will help you compare categories or show compositions, or show you what the composition of that variable is. So bar chart, we know that, we've come across it in the previous slides. A bubble chart, so that's similar to a scatter plot, but you have bubbles that grow depending on the value. A pie chart, again, we've shown that in the previous examples, and a stacked bar chart. So this is a bar chart, but rather than depicting the different groups side by side, you put them one as a continuum to another. So that is a good way to depict composition over time or across categories. Some more of these variations of charts that you might consider is a bubble cloud. So this shows composition across categories, and what you have, the larger the bubble, the greater the value, and then you have different colors for different groups. So another similar one is the tree map. Again, you have squares now, and so you have the big square showing 100%, and you have smaller squares with different colors depicting proportions or of percentages of the larger square. And that's to show, again, composition across categories. It could also be values, not necessarily percentages, that one. And finally, very helpful if you don't have numeric data, but you have words, you could create word clouds of the textual data by, so using word frequencies. Normally, usually, what you would do is the larger the word, the greater the frequency in the specific text. Again, very helpful visualization to show you something about the data, especially the categories and the composition within them. Here I have another example where you have incomes of some of the celebrities, and you can vary. So this is the bubble cloud that we came across a little while ago. So you have the larger the bubble, the larger the amount, and then you have different celebrities named here. So that shows you like how much less, for example, Ray Charles is, according to this infograph, is supposed to have earned compared to Elvis Presley, for example. And as you see, even though this is an infographic, or doesn't have like a y and x axis, it's also always helpful to sort of say where you got the data from and maybe the date of when this data set was created or was extracted from, so as you get a feeling for when this visual was created. So when trying to compare multiple values, bar charts are the best. And as I said, you could use the stacked bar charts to add more than one relationship. So here you see we have, I don't know if you can see that, but I'm sorry, it's a bit tiny, but you can see with the green, so you have different authors, and you have with green the non-fiction authors that they've published, with red the fiction ones, with blue the poetry, and then other literary texts are with yellow. And then you have in the same visualization the stacked bar charts combined with some stars, rewards, or a rating system from 1 to 3, where you get if they've got a Nobel Prize for the first column, Pulitzer Prize for the second column, and other in the third column. Again, you might say this is too complex. I would have just stuck with the stacked bars, but then again, that's kind of an example of what a visual could combine more than 3, in this case, pieces of information for these authors. Going back to the 5 kind of key purposes of creating charts and visualizations. If you're trying to show change, I would suggest you use these types of charts. So a line chart, we've come across this before. It's very helpful when trying to show change over time. And the same goes with area chart. Again, this is giving you, if you're trying to visualize series over time, this is helpful because it gives you a better visual of the kind of a trend. If you would like to show distinct events in time, a timeline might be a helpful way to visualize that. And this might not be in your typical chart like y and x axis kind of visualization, but it could be horizontal or vertical. Normally what happens is you have a timeline that like the one we have here, a beginning and an end, and you have lines depicting years or months, and you can see you can attach either, again, a line chart, or you can attach information about what happened when. Finally, one of the most kind of commonly seen in the latest couple of months in the news is a map chart. And also there are variations of that where you have areas or colored with the same color. So the US elections is one good example where they have two categories. They have the two candidates, and they're coloring each of the states to showcase which one of them has won that specific area. And also, if you were watching it, you could drill down to specific division sub-districts of these states to be able to see what the result was. So that's all very helpful to try and understand on this occasion how US citizens voted. But it gives you a very nice and interactive way to look at that rather than having to go through the table and looking at the numbers. So again, here's another example of using a map series to show changes in location data over time. So we have a combination of more than one things that we want to show. So for example, this is an imaginary example, but 2015, you have some states there were the customers of that company. Then 2016, you see how that company has grown into most of the West Coast countries, as well as some of the central ones. Then you see that in 2017, that gets even greater proportion of customers in these areas. So again, at a glance, you can see how that company has grown over the years in a specific location. Really easy, really good. No numbers. So for decision makers, this is really good to be able to see that trend over time. The fourth purpose would be to try and organize information. So if you're trying to organize information and data, these would be good visualization or charts to use. So a process list, so 1, do this, 2, do this, 3, do this, is a good one if there is a process you're trying to describe rather than numerical data. Flowchart is also very helpful. It's also very good at depicting relationships. So if you're trying, for example, to show how a company is organized, then you would use a process flowchart. You would also use it if you were trying to show in a visual form what are the steps in a decision making process. Venn diagrams are really helpful for groupings and to sort of see how different groups overlap with each other. And finally, a mind map, again, is very helpful to try and understand groupings and connections. Finally, for that category, if you're trying to organize information, some other visuals that you might have come across is the pyramid diagram that shows hierarchy. It has been used upside down as well, and it's called a funnel diagram that shows you maybe how, for example, if you have a company, you want to see how you get from 100% of your customers, how you actually can drill down to the customers that become your loyal customers, for example. So that is a funnel diagram. You'll start from 100% of your total number of clients, and then you probably will end up with maybe 10% or 20% of them that will be returning loyal customers. Don't underestimate the use of a table as a very good way to visualize, despite all that we've said up to now. So it is the best way to visualize many variables with different units. Sometimes it's easier to show information in a table than it is to show multiple relationships of multiple variables in one table. But again, remember, consider what it is that your key message is, and maybe you could break down these relationships into smaller relationships and showcase each one of them separately so that it's easier for the reader. And then if you're trying to, especially if you're trying to show rankings, and especially if it's numerical rankings, the ordered bar chart is also very helpful. So you start from the largest value all the way to the bar chart, but you start from the largest value all the way down to the smallest value. Finally, if you're trying to show relationships between data, between variables, we've come across the scatter plot and we've explained what that is. So it's a very good plot to show you relationships between two variables. A histogram will show you the distribution of one variable. So a histogram looks like a bar chart, but it's slightly different. It shows you how the variable gets distributed over time or over whatever your axis is. Finally, you could use a combination of different types of charts, like a line chart and a bar chart, to show relationships between multiple variables and multiple series over time. So again, this would be helpful to try and showcase relationships or like correlations of distributions over time. So I've added this with no expectation for you to be able to read it at this point in time, but in the materials I will post on our website, you can, of course, view the link, but it's a very interesting decision tree where you start from the middle. What would you like to show? Then you decide whether you want to compare, distribute, showcase a composition or relationship. And it's more or less a decision tree. You just start from the middle, then you go depending on what you're trying to do, whether you want to do one variable, two variables, whether it's over time or over location. So as a way for you to then take away and then see if that helps you decide what will be the best chart. So I'd like to sort of showcase some examples. So data visualization is an art, so you would need to get inspiration from loads of different places. I just want to show you some examples of how people have visualized data, but I mean included these links here as well, you know, you could have a look and see what other people are doing and how they're using these visualizations to convey information. And I'll just finish today's talk and open the floor for questions with this video GIF, which shows how to start from very complex, very cluttered visualization and end up with something that is meaningful and much easier to read. So we start from that. And we remove anything that doesn't include information, removing borders, remove the legend, because you already have the line to connect that. You get rid of the 3D. You get rid of the bolds. You get rid of the multiple colors. You get rid of the wedges because it's not helpful. Really, the information is that. And you use a bar chart instead of a pie chart to be able to get that effect. So on that note, also as you are thinking of your questions and you're typing, we would be grateful if you could tell us what you thought of the session. We have a feedback form that we ask our participants to fill in just to help us plan and improve our future sessions and webinars. So let me just look at what we have in the Q&A in the chat now. So I have a question from Sarah. She's asking, could you recommend any free software for building charts, mind maps, and infographics? So in the link in that I have in the material online, and it sort of replies to the last question as well. I have some interesting links, both for, so let me take you back to the starting slide, which also has the link to the material. So the recording will be available. The material are also available here in this link. But I have added some links in this presentation in terms of ways to actually use your favorite software. I would recommend, if you have a Google account, Google Charts has loads of these charts available for you to play with. If you're using Excel, Excel also has them. And I would recommend you try some of them. But if you are interested in doing something more elaborate with your graphs, there are some very good freely available languages like R. I would highly recommend if you are thinking of, if you were thinking of learning something new, R would be a very helpful tool for you. Sarah, I don't know if you are familiar with R at all, if you come across it. So it's a statistical analysis language, I would say, and it comes with loads of interesting packages, loads of the nice visual plots that you've come across in the Guardian, in BBC, are based on visualizations using R. SPSS should also get you, so SPSS will also give you the opportunity to create charts like Stata, which is a kind of sister software, or MATLAB, which is other kind of statistical analysis software. They are a little bit more difficult to do the combined plots with. So I would say try and look out for SPSS in particular. Try and look out for some of the packages that are available that you could download that other people have written, where they're actually combining line graphs and plots and things like that. But I have used both Data and R and SPSS, and of the three, I think R is my favorite because it lets me do loads of interesting visualizations and combine and sort of customize my graphs really easily. So very happy to send, if you drop me a line, my email is here. If you drop me a line, I'm very happy to send you the slides, but also you could go in that link and download them as well. So let me check, I was checking the chat. Let me check the Q&A now. So Clem is asking, what in your opinion are the most useful tools for data visualization? Tableau or Power BI, R or Python, etc. So this is a very good question, Clem. So I would say Tableau and Power BI are both equally good and sort of powerful when it comes to data visualization. I find Tableau a little bit easier for exploring data than Power BI, especially if you don't have a background in, if you don't want to code much, and if you don't want to sort of worry too much about what the form of your data would be. So both of them actually allow you to drag and drop the variables in various places. So you could explore different groupings and different like orientations and different charts, which is very helpful. R and Python are a bit more powerful, I would say, but they have the disadvantage that you can't drag and drop, which is what Tableau and Power BI offer. So if you don't want to do write any code at all, Tableau and Power BI would be good ones. R and Python are a little bit more flexible because you're writing your code, and therefore you don't need to. You can combine things and you can run scripts, etc. But they don't offer that drag and drop functionality as good as Tableau and Power BI does. So hopefully that's answered your question. And I think Richard's question has been tackled as well. But Richard, let me know if you'd like any follow-up information on that, because Richard is asking what programs would you recommend for data visualization. Good, thank you. We have another comment from Petros. Hi, Petro. He says, my comment is that visualization in working environment, especially in industrial environments, should be kept with less text possible. Thank you for the presentation because it was good and fully understandable. So thank you, Pedro. And it's just to fully sort of second that you would a visualization, a graph, a graphic, an infographic is something which should have as less text as possible, or let's put it the other way, should have as much text as needed for the audience that you are trying to capture. Remember, it's supposed to be an at a glance piece of information, or a picture, or a visualization of information that should stay in somebody's memory without them having to go through the nitty-gritty details and read through it. But at the same time, it should also remember, I don't know if I've mentioned this in the slides, but it should also mention where you took the data from and how, the date of when you created it, because that is also helpful information to put context around the visualization. So just giving it a bit more time. So I don't know, I can't see any further questions. Are there any other questions from the participants? So I have couple more minutes. So as people are thinking, let me show you. I wanted to show you some of these examples of the nice places to get inspiration from. There it is. So and get to. So this is Information is Beautiful. This is a place where I normally go to if I'm stuck. It has very beautiful, very informative, almost pieces of art types of visualization. So this is the good visualization graph I showed you. But let's look at one of the latest ones. So, for example, this one has got information visualizations for coronavirus. So you see, it takes a bit of time, bear with it. So it sort of shows you the usual graph that we all see in the news about different countries, but bear in mind how many they are. So you could drill down by clicking on, for example, Italy, or so you can see that the total cases. You can hover over it and you see Germany highlighted. So here you see infection and fatality rates by country and places. A very interesting visualization here about where is coronavirus rising and falling, and you have the average percent change in weekly cases. And you see how that bar chart now, it looks very different from any of the bar charts we've come across. He's chosen to put it on a kind of radius, on a rather than on a horizontal and vertical axis. So interesting visually. So you see our bubble graphs here, the different activities, and low risk activities, medium risk activities, high risk activities. So that was one. Let me show you another. So this comes from a website called visualization.ch, and it gives you different types of libraries if you were using tools called so let's have a look at CartoDB. So it's a library of different types of visualizations and places to go to. So that gives you spatial analysis types of visualizations. gives you examples of what that is. And the last one was a resource, more or less, for inspiration for how to. So it's a community of practitioners and people who visualize data, both academics and practitioners. And you can see some interesting resources and publications there if you'd like to learn more about information visualization and how to do that. And I can see I have one more chat. So Nigel says we should also consider visual impairment. We should also consider visual impairments when thinking about visuals in your presentation. So absolutely, absolutely. So all the kind of best practices around that apply here as well. So that brings us very nicely to a close. So we would like to thank you for coming along to our webinar today. We would be extremely helpful if you could spend some time to fill in our survey, and I'll just post that to our chat just now, in case you have time to do that before we go. So thank you again. And as we said, recordings and material will be available after this course on our website and on our BLG TV channels. So would be grateful if you have any comments or questions, email us. And stay safe, everybody. Have a good day.